Hi, I'm Frank, manufacturing engineer at Volterra. Today, we're using both V1 and Nova to print dry biomedical electrodes with gold ink. These electrodes, or ECG sensors, will be attached to an adapter board which gathers signals from the heart and interprets them into a graph. Before we can print the dry electrodes, we first need a printer board that will interpret the signals, and we will start by printing this board using V1. The adapter board includes a SparkFun heart rate monitor, AD8232, and an Arduino Micro. Each time the heart's electrical current triggers a contraction, the adapter board detects the change in voltage, causing the LED to flash, essentially mirroring the wearer's heartbeat. The second print is done on Nova. First, a silver trace is printed with Micromax Intexar PE874 stretchable silver conductor paste on TPU. This silver ink can bend up to 180 degrees without losing electrical conductivity. We use silver ink for this step because gold ink is not stretchable and will crack and flake off of the TPU. Our third and final print is done with Creative Materials EXP2613-40 gold ink. Due to the heavy metal particles, the gold ink had to be mixed immediately before printing in order to prevent the particles from settling at the bottom of the cartridge. There are several benefits of printing dry, rather than wet biomedical electrodes, as well as benefits to using gold ink to print them. First, gold isn't reactive and it is one of the most biocompatible metals, meaning there is less of a chance of a harmful reaction with direct skin contact compared to metals like silver. Additionally, dry electrodes generally have a longer shelf life, as wet electrodes can dry out or lose their fidelity over time. Another advantage of dry electrodes is the potential for sterilization and reuse. Once the gold electrode had been printed, a T-shirt press allows us to sandwich a piece of PET between the folded halves of the TPU. This reinforces the print so that it has functionally zero stretch around the gold ink area while still being flexible. This is important because, as mentioned previously, this gold ink is flexible but not stretchable. The electrodes detect when there is a change in the heart's electrical current, sending a signal to the heart rate monitor, then to the Arduino Micro, which interprets the signal and outputs it in graph form. Medical professionals can then analyze the graph to detect indicators of heart performance and health. Ultimately, we were able to prototype functional dry electrodes printed with gold ink while ensuring minimal material waste. It's exciting to see the possibilities that arise from printing novel materials, as well as the doors that developments like this open in the biomedical field.